Be careful this chapter because you're going to find a lot of definitions. A lot. It's a lot of terminology, this chapter. Terminology isn't necessarily math. However, it is math in that if a person says to you coefficient, if you don't know what that means, you don't know what they're saying. When you get to geometry and Mr. B says to you supplementary angles, if you don't know what they are, you don't know what he's talking about. If he says, oh, those angles are adjacent, if you don't know what that means, you don't know what he's talking about. If he says, oh, we have an obtuse angle here, and you don't know what obtuse means, you don't know what he's talking about. He might as well be talking a different language. So it is important that we learn these things. However, it's going to take some review for it to stick. My advice is to just read through your notes occasionally, maybe every other day. Just read through them to keep refreshing your memory of the terminology and the things that we learn. Also, all of the notation. So yesterday's lesson showed you how to do the notation for a line. You've got to do that notation. It's got to be 2 points on the line in capital letters, with the line symbol over top that has the arrows going both ways. If it's a line segment, no arrows up top, and it's the 2 endpoints and all points in between, etc., 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 etc. Ray, a plane, all those things. You need to review that stuff. Okay? I didn't want the homework to be too long, so a lot of that stuff didn't make it into the homework. It doesn't mean that you won't get questions about it. So be careful. But what I'm saying is read over your notes. Read over your notes. John, can you get the door for us, please? Read over your notes because the stuff has to stick. The stuff has to stick. All right, so let's go ahead and do number 1 here. I've broken up lesson 12.2 into 2 parts. So the first part, we'll deal with one aspect, and then we'll finish off with the second part. All right. The first thing is, I'm not going to fill in the first blank yet. We'll get that in a minute. 2 angles where the sum, so the operation class is addition, where the sum of their measures is 90 degrees. So there's a term for when you add up 2 angles and you get 90. Now, to the right here, I'll mention this again in a moment, is the classic example of these kinds of angles. And it's clear from the drawing that they are these kinds of angles. Because notice, don't do this on yours, but notice the big angle. How many degrees is that big angle, class? Say it if you know it. 90, right? You know it because of the 90-degree symbol. Now, I don't know how much either of the angles are, but let's just suppose that angle CBD, the one with the purple arc measure, let's suppose it was 50 degrees. How much does angle ABC have to be? 40, all right? Last time I checked, 50 plus 40 equals 90, all right? Because the whole big 90-degree angle is made up of the bottom angle, angle CBD, plus the top angle, angle ABC. And therefore, then, together, they equal 90, and they're this term for the 2 angles together. Any 2 angles where you add them up and you get 90 have this term. All right. So, again, I don't know if that's actually 1540. I'm just throwing out some stuff. Anybody know the term for 2 angles where their sum is 90? Jordan? Adjacent? Which one you picking? No. Nick? Complement. All right. Complement is a shortened form of the word. These are complementary angles. Complementary. It's spelt like complementary. All right. C-O-M-P-L-E-M-A complementary. T-E-R-Y. I think that's spelt right. T-A-R-Y. Is that right? Complement. No, that's all goofed up. Oh, brother. Good thing I didn't have to spell in college. Complementary. 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 It's spelled that way, but we say complementary. And Nick used a form of the word when you're talking about two angles. When you talk about the two angles, we say they are complements. Complements. So the two angles together are complementary angles, and you could say that they're complements. All right, so off to the right is the common example. And we know that they're complements even without knowing how many degrees each one is. Because we know that together those two angles make a right angle, and therefore they have to be complementary because the two of them together have to equal 90. We know it's the case. It has to be. It's a common example. And by the way, they could be rotated any amount of degrees, right? Obviously, this angle and this angle, right, if that were a right angle, are both complementary angles, right? The two of them equal 90. That's the common situation. Do they have to be right next to each other? The answer is no. Here in this second example, if the measure of angle P is 58 degrees, then angle P and angle Z are complementary angles. They don't have to be right next to each other, forming a right angle. You could have one angle over there and one angle over here. As long as the two angles together equal 90 degrees, we'll call them complementary angles, right? So complementary, two angles where their measure is 90. So then sometimes you'll get a problem like this. If the measure of angle JKL equals 70, find its complements. Well, you use the fact that you know that together the two angles are 90, right? If you'll then simply subtract the one you know from it, I'm going to use my black for the 70, or I thought I was going to use my black. Then what's left is going to be its complement. When you finish this off, we all know 90 minus 70 is 20. So does that make sense? If two angles together equal 90 and one of them 70, how much does the other one have to be? 20. So let's do some mental math. We got complements, right? We got two angles added up to 90. One of them's 10. What's the other? 80. It has to be. One of them's 1 degree. What's the other? 89. All right. 89 plus 1 is 90. Sorry, folks. All right. They have to add up to 90. One of them is 60. The other one is 30. One of them's 45. The other one is, right? They have to add up to 90. So again, if it's something odd, just take 90, subtract what they tell you, and what's left will be its complement. Two angles where their measure is 90. All right, so go ahead and do D. Find the complement of a 32-degree angle. What is the complement of a 32-degree angle? And it's just like example B, isn't it? Last time I checked, 90 minus 32 is 58. Don't mess up with your math, because you know what? You have a calculator. If you can't do it in your head, punch in 90 minus 50 or 32, and your calculator will say 58 degrees, right? Don't mess those up. You don't want to mess up problems like that. They should be easy, all right? Again, if the angle was 5, its complement has to be 85. The angle's 15. Again, you got to be careful. 90 minus 15. All right. Let's continue on. Well, that's complementary angles. The next thought is, what do we call two angles where the sum, there we are again with the sum, of their measures is 180 degrees. This is a different term. So complementary angles, two angles where their sum is 90 degrees. What do we call two angles where their sum is 180? Jordan. Not going to go for it, Jason, huh? Good choice. Supplementary. Spelt like supplementary. 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 All right, supplementary. I don't know about you, but for me, I just remember they're alphabetical. 90 comes before 180, C comes before S. But you don't want to think of two that add up to 90, you don't want to call supplementary. And you don't want two that add up to 180, you don't want to call them complementary. Don't get them flip-flopped. Okay? Supplementary add up to 180, complementary add up to 90. All right, the common example is here on the right here. And it's the common example because we have a straight angle. And we have two angles together to make up the straight angle, right? Here, I'll use my color. Here's angle, you don't need to do this in your notes, HGJ. I don't know how many degrees it is. Looks like it's maybe about 50. I'm going to use yellow. And then I have this angle, angle FGH. Don't the two of them together have to equal the whole 180 degrees? Because the two of them together make up that big angle. So again, if this one would be 50, then this one would have to be 130. Has to be, because the two of them make that straight angle. That's the common example. You know they're supplementary because of that straight angle. And again, this straight angle could go anywhere. What if the straight angle was like this, and then you had an angle coming off? This angle plus this angle have to equal 180, don't they? They do. And there's no other possibility. From here to here gets you part of the 180, and from here to here gets you the rest of the 180. They've got to be supplementary. There is no other choice. Let me get that higher for you guys. Okay, there's no other choice. It's got to be. That's the common example. So here, if I said to you for B, angle K and angle L are supplementary angles, then you'll know that angle L has to be, are you ready? Mental math. How many degrees is angle L? Has to be 130 degrees. It has to be. If I told you they're supplements, then it has to be. If angle K and angle R are supplementary angles and K is 50, then L's got to be 130. Let me ask you this. Can two acute angles be supplementary angles? Can two acute angles be supplementary angles? It's impossible. You will never add up to 180. Can two obtuse angles be supplementary angles? No, because you'll always be over 180. So supplementary angles must always be either one acute and one obtuse, or, anybody know the other possibility? Two right angles, right? Is the only possibility. How about complementary? Can you have one acute and one obtuse and then be complementary? No. It's got to be two acute, right? All right. So same kind of logic as before. Let's do a little mental math, all right? Here we go. I have a 100-degree angle. Its supplement is 80 degrees. I have a 150-degree angle. Its supplement is 30 degrees. I have a 40-degree angle. Its supplement is 140 degrees. So when you get a problem like this, it's the exact same thing you're doing in your head. Hopefully you're trying to figure out 17 and what adds up to 180. And the way you can do it is simply subtract the 17 from the 180, or figure out how much to go from 17 to 180. Either way is going to get you there. And again, don't miss these because you got a calculator. And what's that, 163? Yes, it is. 163 degrees is the supplement. Okay? Don't miss those. Hey, if I give you a homework problem, just show that it just takes a second to show 180 minus 17, all right? I don't need to see anything else. If they ask for an equation, that's sufficient for the equation, okay? All right? Because I know the book likes to do that. And we could do all the letter kind of thing, but we'll save that for when you're in geometry with Mr. B. So if the book asks you for an equation, this is sufficient for the equation. If you want, you could put equals x, for the angle and then finish it. But that's all you need. All right, so far this is what we've talked about. Complementary angles, two angles where they add up to 90. Supplementary angles, two angles where they add up to 180. Next page. All right, what do we got? Another couple examples here of supplementary angles. So what is the measure of angle DEF? First off, you have to know where angle DEF is. Hey, remember, the vertex is always in the middle, right? So this is the vertex. D is a point along one ray, and F is a point along the other ray. So I'm looking for that angle. So I look at this and say, oh, that's the common example of supplementary angles. Therefore, angle DEF must be the supplement to the angle given. So again, then you're going to say, that's just 180 minus the angle I know, which is 148. Or again, you're going to start at 148, count up to 180. Either way will get you there. But what's the measure of angle DEF, Nick? 32 degrees. And again, you got a calculator, so don't miss those. Those aren't supposed to be hard. All right, what if this happens? Two straight angles. Remember, a straight angle looks like a line. Two straight angles form two pairs of supplementary angles. And really, you can look at this a bunch of different ways. Take your green. Let's use the green line, and let's go on top of the green line. See, angle 4 and angle 1, aren't they supplementary angles? All right, so angle 4 and angle 1 are, and I'm just going to go SUP and abbreviate, are supplements. Do you agree? Angle 4 and angle 1, according to that green line being the straight angle. And look, can't you do the same thing on the bottom side? Go on the bottom of the green line. Do you see that pair of supplements? Okay. So you got angle 3 and angle 2 are also supplementary angles. Now let's use the black line. Go above the black line. Aren't angle 1 and angle 2 supplementary angles? All right, now we're using the black line. And go below the black line. Aren't angle 4 and angle 3 supplementary angles? So you get a green pair of supplementary angles and a black pair of supplementary angles. All right, and there's really 4 sets of supplementary angles there. If you go by the green line, 4 and 1 and 3 and 2. If you go by the black line, 1 and 2 and 4 and 3. So a lot of different ways that works. We're going to look at some relationships of that in just a moment. So there's a lot of supplementary angles when you have straight angles. All right, number 3. Jordan used this word a little bit ago. She used the word adjacent. A-D-J-A-C-E-N-T, adjacent. What are adjacent angles? They are angles with a common vertex and a common side. And maybe it would be best if we say a common interior side. I don't know. That's not the best word. You know what? We'll just leave it. I'll explain it and it'll be fine. But if you look at the example here to the right, you'll look right here, right? What we've got here is we're going to use B as our common vertex. So what we have is we have angle ABC. And here I'm going to go in yellow, right? Would you agree this is angle ABC right there in yellow? Yes? Okay. And I'll leave that in yellow. And its adjacent angle would be angle CBD. Angle CBD. And I'm going to do angle CBD in purple. So if you look up, isn't this angle CBD? Now, do those two angles have the same vertex? Do they have the same vertex? Yes. And do they share a ray in the middle? Yes. That's the term for adjacent angles. All right, so let me go back a second here for you guys. When we did the common example of complementary angles, are they also adjacent angles? Yes. Are these two adjacent angles, though? No. So the common example involves adjacent angles. The non-common does not. Same thing with supplementary. Here's the example of the common example of supplementary. Are they adjacent angles? Yes. They share the same vertex and a common ray. Here's supplementaries. Are they adjacent? No. Okay. So adjacent angles. So you'll see them a lot, and you'll see them all over the place. B. Two straight angles form two pairs of vertical angles. Vertical angles. Vertical. I don't know, I got extra letter in there. Vertical angles. Two straight angles form two pairs of vertical angles. Each pair of vertical angles, and this is the key concept with vertical angles, have the same measure. Each pair of vertical angles have the same measure. I tried to use a little color to help you guys out with this. Jack, let me do one thing and I'll take your question, okay? So if you look at the orange angle, the 1 and the 2 and the 3 and the 4 aren't the number of degrees. It's another way of identifying an angle. Instead of using the three-letter approach, if we put a little number in the crevice of the angle, I could say angle 1. Would you know which angle I'm talking about if I said angle 1? It's the orange angle. If I said angle 2, would you know what angle I'm talking about? It's the purple angle. Angle 3 would have the one orange side and the other purple side, right? And angle 4 would have one orange side on the left and the purple side on the right, right? You follow? So it's a shorthand and it's kind of handy. So here's what we're saying. We're saying the measure of angle 1, that orange angle, equals the measure of angle 2, its vertical angle. They're right across from each other vertically. So 1 and 2 are vertical angles, right? And we're also saying this. The measure of angle 3 must equal the measure of angle 4. They are vertical angles. If you guys get a little time on your own, you can take your protractor out and measure those angles. And if you take your protractor out, and if I had time, I'd love to do it, take your protractor out, measure angle 1. I don't know, looks to be somewhere around 40 degrees, maybe 37, something like that. If I measured 2 with my protractor, it would be the exact same measure. Now, angle 3 is what kind of angle? Obtuse. So it's going to be over 100. Over 90 definitely looks to be well over that. And if I were to get my protractor out and measure it and then measure angle 4, you know what? They're going to be exactly the same. Here's a term that we don't really have in our notes, but I'm going to give you this term. Two angles, when their measures are the same, are called congruent. Congruent. Anybody ever heard that term before? Congruent? Okay. By the way, the symbol you may have seen before, it's an equal sign with the tilde over top. This is a congruent symbol. And let me show you the difference here. Whenever Earth 2 Daydreamers or whatever, whenever you're talking about how many degrees an angle is, degrees can be equal. Measure of angle 1 means how many degrees it is. Measure of angle 2 means how many degrees is it. Whenever you talk about the angle itself without the M symbol, if they're the same amount of degrees, the angle themselves can be congruent, meaning same size and shape. So angle 1 is congruent to angle 2. Measure of angle 1 equals the measure of angle 2. All right, that's the concept. Let's get to our, I think, the last example, huh? At least of 12.2a. All right, so look at the situation. I say the measure of angle 8 is 32 degrees. I'm going to take my black here, and I'm going to write in 32 degrees by angle 8. Just to help me visualize. You should do that as well. Find the measure of all the other angles? All right. Can somebody give me the measure to one of the other three angles? Raise your hand. Oh, Jack, we never got back to your question. Give me one other angle. Who can give me one other angle? Tell me which one and how many degrees. Blake? All right. I think Blake just said to himself, you know what? 6 is the vertical angle, so 6 has to be 32. Do you agree? You should. Vertical angles always have the same measure. And 6 is the vertical angle to 8, so it's got to be 32. Okay, 2 down, 2 to go. Andrew, can you give me another one? 5 is 52. Not quite. No. Not quite. Nick, what do you got? 148? 148? Anybody agree with Nick? 148? How in the world did Nick, can somebody explain how Nick got that? Not Nick. Can somebody explain? Eduardo, how did Nick get that? Why did he do that? Ah, because Nick saw, look, Nick saw that these two angles are supplementary angles, right? And therefore, he said if one of them's 32, the other's got to be 148 to make up 180. That is the case. All right, if number 5 is 148, can anybody give me 7? 7, Raquel. Because those are vertical angles, correct. And so whenever you have two pairs of vertical angles, if you know one, you can get all the others. Jack, question. By definition, it is just 2. I mean, you can have 3 angles that together equal 180, but you would not call them supplementary. They would be 3 angles. 3 could make 180, 4 can make 180, but by the definition, supplements only using 2 of them. All right, we'll pick up here tomorrow. Let me get your attention, please. If for some reason you're not in school tomorrow, make sure you look on InfoDirect. Again, my plan is to have you working on homework in class tomorrow and hopefully get it done so that you leave tomorrow with no homework, all right? But if you're absent tomorrow, not here, then you need to do the homework. All right, you can now pack up.